Remember those old cartoons where robot maids cleaned houses while families lived in flying cars? That future just became available for pre-order. For $20,000 or $500 per month, you can reserve a humanoid robot that folds laundry, loads dishwashers, and greets your guests. It ships in 2026. But there's a catch nobody's talking about, and it reveals something crucial about where AI is actually heading. A company called 1X just launched Neo, marketed as the first large-scale commercial humanoid robot designed specifically for home use. The pitch is compelling. A 30-kilogram robot with soft polymer skin, 22 degrees of freedom in its hands, and movement smooth enough to handle delicate tasks. It charges itself, operates for 4 hours on a battery, and learns your home's layout through its cameras. You control it through a smartphone app, telling it to tidy rooms, water plants, feed the dog. The vision is Rosie from the Jetsons. Finally real. The timing isn't coincidental. 2 weeks before Neo's announcement, another company called Figure unveiled a new version of their humanoid. Tesla's Optimus continues making aggressive promises. Morgan Stanley projects 1 billion humanoid robots worldwide by 2050, creating a $5 trillion market. That's double the size of the entire automobile industry. According to their forecasts, 10% of American households could have a humanoid robot by 2050. We're watching the birth of an entirely new category of consumer product. But here's where the marketing diverges sharply from reality. The Wall Street Journal conducted the first independent test of Neo. The results were revealing. The robot took over a minute to remove a water bottle from a refrigerator, 5 minutes to load 3 glasses and a few plates into a dishwasher, 2 minutes to fold a single towel. And its movements weren't smooth or efficient. They were slow, hesitant, uncertain. That's notable but not surprising. Early technology is always clunky. The real issue runs much deeper. To perform these tasks right now, a human operator needs to remotely control Neo. Not sometimes. Not for complex tasks. For everything. The $20,000 robot you're buying isn't autonomous. It's a telepresence device, controlled by someone in a different location, wearing VR goggles, seeing through the robot's cameras in your home. The company's CEO admits this openly. Anyone receiving Neo in 2026 must accept that human operators will control it remotely inside their homes. Why? Because the AI model hasn't collected enough real-world data yet. Neo needs to learn by watching humans perform tasks through its cameras, converting those movements into training data for its AI system called Redwood. Think about what this means practically. You tell Neo to load the laundry. You give permission. An operator wearing VR glasses sees your house through the robot's cameras. They control its movements remotely, sorting through your clothes, handling your belongings, seeing your living spaces. The system records everything as training data. Eventually, through enough examples, the AI learns to generalize and perform tasks independently. But that eventually could take years. This isn't unique to Neo. It's actually the fundamental challenge facing every humanoid robotics company right now. Tesla's Optimus uses a system similar to their full self-driving approach, collecting data from real-world scenarios. Other companies hire employees specifically to teach robots basic tasks. The problem is simple but massive. AI has consumed everything on the internet, but lacks physical knowledge of the real world. Large language models read billions of text documents. Image generators trained on billions of pictures. But folding a towel, loading a dishwasher, those require understanding physics, spatial relationships, material properties, force application. That knowledge exists primarily in human muscle memory, not in datasets AI can easily consume. So humanoid robots need to learn by doing, which means they need humans demonstrating tasks thousands of times. This creates what the industry calls a teaching cycle. A remote operator performs a task through the robot. The AI observes and converts movements into data. Redwood, Neo's AI brain, makes generalizations about when to apply specific movements. When it encounters a new situation, it tries to generalize from previous examples. If it gets stuck, expert mode activates, and a human operator takes control to demonstrate the correct approach. Each successful teaching makes Neo smarter, not just for that specific robot, but potentially for all Neo units, since they can share learned behaviors. That's the advantage of this approach. Every early adopter essentially becomes an unpaid AI trainer, generating valuable data while paying $20,000 for the privilege. But let's address the elephant in the room: privacy. You're putting cameras and microphones throughout your home, controlled by a device that remote operators can access. They can see your kitchen, living room, potentially your bedroom. The company acknowledges this and promises safeguards, blurred faces, restricted areas you can define, app controls for when operators can activate. But the fundamental vulnerability remains. You're allowing strangers visual access to your private spaces in exchange for robotic assistance that's currently slower than doing tasks yourself. The security implications extend beyond privacy. These robots connect to IoT devices, your smart locks, security systems, thermostats. What happens when Neo starts interacting with those systems? What happens if an attacker compromises the robot and gains access to your connected home infrastructure? These aren't hypothetical concerns. They're foreseeable risks that currently lack adequate answers because standards don't exist yet. Regulations haven't caught up. The technology is moving faster than the frameworks meant to govern it. Research published in Expert Systems shows that humanoid robots can exploit human psychology. We develop emotional attachments to objects. We extend empathy to robots. We trust them with sensitive information. That trust creates vulnerability that malicious actors or poorly secured systems could exploit. Yet despite these obvious issues, investment continues pouring in. OpenAI, the company behind ChatGPT, is an investor in 1X. Major firms are betting billions on humanoid robotics. Morgan Stanley predicts 8 million humanoid robots working in America by 2040, creating a $357 billion wage impact. They estimate 70% of construction jobs and 67% of agriculture and forestry jobs are at risk from robotic automation. China is treating this as a geopolitical priority. The Chinese government projects 302 million robots in China by 2050, making it the world's largest robot population. They're providing massive support for embodied AI development. This isn't just technological competition. It's a race to control the future labor economy. Whoever dominates humanoid robotics first shapes how work, employment, and economic value function in the coming decades. So, what's actually happening here? We're watching the collision between ambitious marketing and messy reality. The vision of autonomous household robots is compelling and probably inevitable eventually. But the path from here to there runs through an awkward phase where robots are actually remote-controlled telepresence devices generating training data while slowly learning to function independently. This mirrors the pattern we've seen with other AI technologies. Self-driving cars were supposed to be everywhere by 2020. Instead, we have advanced driver assistance systems that still require human attention. AI chatbots were supposed to replace customer service. Instead, they handle simple queries, while complex issues still need humans. The technology improves continuously, but the gap between marketing promises and practical capability remains stubbornly wide. The question isn't whether humanoid robots will eventually clean our homes autonomously. The question is, what happens during the transition period when they're expensive, slow, require remote human control, and introduce new privacy and security vulnerabilities? Are early adopters paying $20,000 to be beta testers, generating training data for companies that will eventually profit from truly autonomous systems? Almost certainly yes. Edison said in 1880 that electricity would become so cheap only the rich would burn candles. At the time, most people in even developed countries washed clothes by hand in public pools. The idea of household appliances powered by electricity seemed impossibly futuristic. Now we can't imagine life without them. Perhaps humanoid robots follow the same trajectory. The clunky, expensive, privacy-concerning versions we see today become the quaint precursors to ubiquitous, affordable, genuinely autonomous assistants. But that transformation won't happen in 2026. It won't happen because one company solved the technical challenges. It happens through the slow accumulation of training data, gradual AI improvements, iterative hardware refinements, and eventually, infrastructure that makes robots as commonplace as washing machines. We're at the very beginning of that process, in the phase where the technology barely works and costs far more than it provides in value. The humanoid robot revolution is coming, just not the version being advertised, not next year, and not without raising fundamental questions about privacy, security, labor, and what it means to invite autonomous systems into our most intimate spaces. The future might be inevitable, but the present is messy, expensive, and requires far more human involvement than the marketing suggests. If this changed how you see the robotics hype, hit that like button and subscribe. Drop a comment with whether you'd pay $20,000 for a robot that needs remote operators. Thanks for watching.